Hi, welcome to ClickMyProject.com.
Title: Learning Spatial and Temporal Extent of Human Action for Action Detection. Modified title: Human Action Recognition using a Joint Learning of Framework. Modified abstract: Human action recognition is the process of labeling image sequence with action labels. Problem solution to this problem have application in domains such as visual surveillance, video retrieval, and human-computer interaction. The task is challenging due to variation in motion performance recording interpersonal difference. This project proposes a joint learning framework to identify the spatial and temporal extent of this action. Interest in training videos. Existing system. In existing system, several approaches were proposed to improve the performance of dense trajectory action recognition in different way. The motion segmentation algorithms apply to divide dense trajectory into several groups. This approach used to use the relationship of these groups to capture the spatial temporal structure of action. In provide for informative representation, the salience mapping algorithm employed background feature. Existing system disadvantage: difficulties action detection distance accumulation of partial observation of signification viewpoint. The performance of the later logic depends the reliable human detection and tracking, which itself challenging problem when applied to real environment. Low quality. Proposed system. In proposed system, the system proposes a joint learning framework. This algorithm is to identify the spatial and temporal extent of action interested training video simultaneously. This method uses the dense trajectory extracted from video's local feature to represent action to get picture level localization result. The system presents a trajectory split and merge algorithm to segment a video into background several separate forward moving objects. Proposed system advantage: the most relevant portion of the action interested each positive example can be effectively identified for detection improvement. The more increment trajectory can be identified for representing and recognizing the action. It provides more effective way to improve the discriminative power of dense trajectory and learning spatial temporal extent. It's requires much less supervision. It's worth emphasizing training phase. It can produce better recognition performance. Flow diagram. First you can select a video, so positive example video it will be better. You can select the video and human being activity video, any one of them, and convert a first frame conversion. After each frame conversion you can detect pre-processing. Pre-processing means image noise deletion function, binary image display, noise reduction, all this function it will be pre-processing. After then camera and HOG edge detection it will be fine for this image of frame. After then split and merge algorithm you can apply, and trajectory prediction function you can use for image segmentation, and apply the spatial temporal method to split the SVM classification model representing for foreground and background image. So the frame outline and center point you can detect, and finally you can detect for this action detection for this human. So running, boxing, any one of them what will be do in video, that will be you can detect the action. Learning spatial action detection. First you can use the MATLAB 2013. I will use the software. So how to I will run this program means, just this is command window, this is current folder. What will be I will opening the testing.m file. So the testing.m file it will be open. This is the program coding. Okay, so it will be the program. So you can just save and run this coding means, so it will be on run. So you can select the data set, specify any one of the video. I will select 6 for example means, it will be run, and you can get this workspace for output. So it will be run. So first you can convert the frame conversion video first, and next frame conversion. That frame conversion, all frame you can get the noise and binary gray and noise reduction, RGB panels, all the pre-processing it will be detect, edge detection, and then original image. The all frame we have selected in separate one image. After original image you can select for this next process. So the next process is binary image and deletion, noise and grayscale image. After the original grayscale image, you can analyze the histogram of original image. So this is the histogram level. It will be increase and decreases simultaneously for this process of human being. After then you can calculate the HOG and noise reduction. So HOG and noise reduction you can calculate. So you can calculate this noise reduction for action in human being. So it will be calculate the every pixel size or every frame n frames. So first you can, for the original grayscale, the histogram original image, it will be simultaneously increase. After then you can calculate this one. After then you can next you can get the HOG centroid points. After you can detect for the Cabur. So the Cabur HOG if you are detect means you can definitely find out the action for the human beings. It will be on central points detection and HOG. After then Cabur. So the HOG is the number of frames. I will given 40 frames means 40 frames it will be. Cabur means it's the same feature points. I will give the frames. How many frames? 80, 40 means it will be calculate this much level. So after the Cabur HOG you can next go to this foreground and background image. After foreground background you can split the image, split the function of human action. After you can detect the final what is the action it will be doing in video. So split the image, running, it is the action detection. This way you can get the output.